Good morning, dear students. Today we shall see the natural coordinates for triangular elements. We have a three-noded triangular element here. The reference frame is OXY. Reference frame is OXY. This is node 1, this is node 2, this is node 3. And we have three natural coordinates L1, L2 and L3 for any point in this three-noded triangle. Right? Each node is specified by the coordinates x and y. For node 1, what are the coordinates x1 and y1? And node 2 is specified by the coordinates x2 and y2. Node 3 is specified by the coordinates x3 and y2. Where P is the point of interest, its coordinates are say x and y. Right? And L1, L2 and L3 are the natural coordinates at the point of interest P. Okay. Now, from the definition of natural coordinates, we write L1 plus L2 plus L3 equals to 1. Sum of the natural coordinates is unity. We know this. And next one. Here, the x coordinate of the point of interest is defined as L1 x1 plus L2 x2 plus L3 x3. The y coordinate of the point of interest is defined as L1 y1 plus L2 y2 plus L3 y3. Okay? Now, we can write this set of equations in matrix form. How we write? Where L1, L2 and L3 are the natural coordinates. Therefore, I consider a matrix with elements L1, L2 and L3 as the column matrix. Okay. Now, how we represent this set of equations in matrix form? A matrix of size 3 by 3 having elements 1, 1 and 1 in first row, x1, x2, x3 in second row, y1, y2 and y3 in third row into a column matrix having the elements L1, L2 and L3 which equals to a column matrix having the elements 1, x and y. Right? This set of equations is represented in matrix form like this. Now, what we want? We want the natural coordinates L1, L2 and L3. Therefore, a column matrix having the natural coordinates L1, L2 and L3 which equals to, right, inverse of this 3 by 3 matrix into a column matrix having the elements 1, x and y. Okay. Inverse of this matrix we have to determine. Then we have to multiply with a column matrix having the elements 1, x and y. Okay, then only we get L1, L2 and L3. Now, here when you determine the inverse of this matrix, okay, we want the determinant of this matrix also. We want the determinant of this matrix also. Therefore, firstly let us see the determinant of this matrix. Okay. Now the determinant of 1, 1, 1, x1, x2, x3, y1, y2, y3. That we see now. Determinant of this matrix, if you determine, how you get, x2, y3 minus x3, y2 minus of x1, y3 minus x3, y1 plus x1, y2 minus x2, y1. Right? So, determinant of this matrix is this. You get this. Okay. where what are x1, y1, x2, y2 and x3, y3? They are the Cartesian coordinates of the nodes 1, 2 and 3 respectively. x1, y1 are the Cartesian coordinates of the node 1. x2, y2 are the coordinates of node 2. x3, y3 are the coordinates of node 3. Okay, now next, what we do is we take the same triangle, right? OXY, as we know, is the reference frame. Now, so this is the three-noded triangle considered. I have drawn a line perpendicular to x from A, right? Which means here, this is the point D. And from C, I have drawn a line vertically to meet x, which means x-axis at point E. Now, I have drawn a line vertically from B to meet x-axis at F. Remember, these are right angles. These are right angles. Therefore, the lines drawn are perpendicular to the coordinate axis x. Now I determine the area of this triangle. Area of this triangle, if you determine, right, how you get? That we see. Area of the triangle ABC equals to, now, area of the figure ADEC. That is what we write here. Area of the figure ADEC plus, next, area of the figure, observe carefully, CEFB, this one, right, minus area of the figure ADFB, this one. Okay, then we get the area of the triangle ABC. Observe carefully. I want area of the triangle here ABC. How I get? Now, area of the triangle ADEC, this one, plus area of the figure CEFB minus area of the figure ADFB. Then only I get the area of the triangle ABC. Okay, now area of figure ADEC, how we get? Observe carefully. Figure ADEC, it is looking like a trapezoid. It is looking like a trapezoid. ADEC. Okay. Now, area of this figure ADEC I want. Now, how I get? So here, area of this figure ADEC is half into, right, AD plus CE into DE. Observe carefully. Area of figure ADEC equals to 1 by 2 into AD plus CE into DE. Okay? Now, what is AD? It is simply the y coordinate of A, that is y1. Therefore, 1 by 2 into y1 plus, what is CE? It is simply the y coordinate of C or node 3, I say y3. Okay? Into, now DE. What is DE? It is simply, x3 minus x1. Therefore, x3 minus x1. That is what I write here. Observe carefully. 1 by 2 into y1 plus y3 into x3 minus x1. Okay, next one. Now, area of figure CEFB. CEFB. Figure CEFB is also looking like a trapezoid. Therefore, How you get the area of figure CEFB? Again, half into CE plus BF into EF into EF. Okay, therefore, which equals to half into, what is CE? CE is simply the y coordinate of node 3, that is y3 into y3 plus what is BF? It is simply the y coordinate of node 2, therefore y2 into EF. How you get? EF equals to here x2 minus x3. EF equals to, observe carefully, EF, how you get? This is, this is x2. This is x2. Understand? Now, what is this? This is x3. Therefore, EF equals to x2 minus x3. In place of EF, you can write x2 minus x3. That is what I write here. 1 by 2 into y3 plus y2 into x2 minus x3. Next, minus 1 by 2 into, now, AD plus BF into DF. 1 by 2 into AD plus BF into DF. It represents area of figure ADFB. Right? Now, 1 by 2 into, in place of AD. What is AD? AD represents simply the y coordinate of node 1, that is y1 plus BF. What is BF? It represents simply the y coordinate of B. Therefore, y2 into, now, DF. What is DF? DF is simply x2 minus x1. Therefore, x2 minus x1. I have written. This is how we have to write carefully. Right? So, once you write like this, you can expand. And you expand, you get an expression like this. Then simplify. When you simplify, you get 1 by 2 into, y1 x3 minus y3 x1 plus y3 x2 minus y2 x3 minus y1 x2 plus y2 x1. You get like this. Okay. What it represents? Area of triangle ABC. Okay. Now, which equals to 1 by 2 into, again, the same expression you can write like this. The same expression you can write like this. 1 by 2 into x2 y3 minus x3 y2 minus half x1 y3 minus x3 y1 plus x1 y2 minus x2 y1, which equals to 1 by 2 into, right, determinant of that matrix. We have determined the determinant of that matrix. What it is? So you go back and see. Determinant of this matrix. Determinant of 1, 1, 1, x1, x2, x3, y1, y2, y1. Okay? So when you determine determinant of this, you get like this. The same we also had there. Therefore, you get. Right? Now, so determinant of that matrix equals to 2 into area of the triangle ABC. We have, here 1 by 2 in determinant. So, area of the triangle equals to 1 by 2 into determinant of that matrix. Okay. Therefore, determinant of that matrix equals to 2 into area of the triangle, that is 2A. We write here. Okay. Now, again, what we want? We want L1, L2, L3. Therefore, L1, L2, L3 equals to, right? L1, L2, L3 equals to, let us see here. L1, L2, L3 equals to, right? Inverse of this into a column matrix having 1 x and y. Now, inverse of this we write now. Therefore, L1, L2, L3 equals to, now, equals to 1 by determinant of that match, that is 2A, into transpose of, into a column matrix having the elements 1, X and Y. Okay, now this equals to 1 by 2A into, now again transpose of this, if you write like this, if you get like this, transpose of this you get like this, understand, into a column matrix having the elements 1, X and Y. Okay, now what I do is, I have here x2, y3 minus x3, y2. Right? In place of this, I put say a1. Next a2. x1, y3 minus x3, y1. I put say a2. Similarly, in place of x1, y2 minus x2, y1, I put a3. Right? And other elements also I define like this. So b1, b2, b3, c1. Right? This is C2. This is C2. No, sorry. This is C3. A3, B3, A3, B3, A1, B1, C1, A1, B1, C1, A2, B2, C2. Correct. This is C2. A3, B3, C3. This is C3. Now it is right. Make correction. Okay? A2, B2, C2, A3, B3, C3. This is C3. Make correction. C3. This is C2. Okay now? Now x2, y3 minus x3, y2. I say A1. Now B1. I say y2 minus y2. Okay? C1 I say x3 minus x2. Right? Similarly, other elements also I define like this. Now, so what you get? A column matrix having the elements L1, L2, L3, which equals to, when you multiply, right? These two matrices, after replacing each element, by the respect to, arbitrary constants. Okay, what you get? You get like this. L1, L2, L3, the natural coordinates equals to A1 plus B1x plus C1y divided by 2A, A2 plus B2x plus C2y divided by 2A, A3 plus B3x plus C3y divided by 2A. You get like this. After multiplication, you get like this. Okay. Now we shall see what is this A1 plus B1x plus C1y. What it gives us. Okay. Observe carefully. Here we have a three-noded triangle. OXY is the reference frame. P is the point of interest. Now this point of interest is joined with vertices like this. A, B and C. Right? This vertex denotes node 1, this denotes node 2 and this denotes node 1. Okay. Now, when P is joined like this with each node, okay. Now, after joining P with each node, the whole area is divided into 3 sub-areas. Okay. Now the area opposite to node 1, I denote by A1 as so. The area opposite to node 2, I represent by A2. The area opposite to node 3, I represent by A3. Okay. What is A here? A is simply the area of this triangle ABC. Okay? Area of the triangle ABC. We have determined the determinant of this, determinant of 1, 1, 1, right? x1, x2, x3, y1, y2, y3. We have determined the determinant of 1, 1, 1, x1, x2, x3, y1, y2, y3. We have that value. Understand? Right. Now, we determine the area of the first triangle, A1. Right? Area of the first triangle. Area of the first triangle, how you get area of the first triangle? A1 equals to x2 y3 minus y3 minus x3 y2 minus of xy3 minus x3y plus xy2 minus x2y divided by 2. Or what you do is twice the area of triangle CPB. Determine carefully, because we have the coordinates of P. The coordinates of P are x and y. The coordinates of B are x2, y2. The coordinates of C are x3, y3. Okay. Now, twice the area of this triangle, that is 2A1 equals to, you get determinant of 1, 1, 1, x, x2, x3, y, y2, y. Twice the area of the triangle CPB equals to determinant of this. Right? Now, that is 2A1 equals to, if you determine the determinant of this, you get like this. Simplify. When you simplify, you get A1 plus B1x plus C1y. We have assumed what is A1, what is B1, what is C1. So therefore, this expression you can represent like this. Right? Hence, what we know here, we know that 2A1 equals to A1 plus B1x plus C1. In this place, you can put, okay, 2A1. If you put 2A1, what you get? L1 equals to simply A1 by A. Next, similarly, A2 plus B2x plus C2y, this you determine. This you determine. How? Now what to do is, take the triangle opposite to node 2, this one. This is the triangle opposite to node 2. This you take and determine. If you determine, you get 2A2 equals to A2 plus B2x plus C2y. You get like this. The procedure what we have followed for 2A1, if you follow for 2A2, you get 2A2 equals to like this. Right? Therefore, in place of this, you can write 2A2. Then what you get? L2 equals to A2 by A. Next, L3. To determine L3, determine this A3 plus B3x plus C3y. Okay? When you determine what you get? A3 plus B3x plus C3y, you get 2A3. That is twice the area of the triangle ABP. You get A3 plus B3x plus C3y equal to twice the area of the triangle ABP. Right? Therefore, L1 equals to simply A1 by A, L2 equals to A2 by A, and L3 equals to A3 by A. Here, the natural coordinates L1, L2 and L3, what they represent simply area coordinates. because L1 we get A1 by A, L2 we get A2 by A, and L3 we get A3 by A. What we understand from this? We can understand that the natural coordinates represent the area coordinates. The area coordinates. That is what we see here. That is what we see here. The natural coordinates L1, L2 and L3, natural coordinates L1, L2 and L3 represent area coordinates A1 by A, A2 by A and A3 by A. Okay? This is the reason why if you take a triangle like this with nodes 1, 2 and 3, right? Okay? And I choose a point P as the point of interest. I join P with each node. Therefore, this is the sub-triangle. Its area is A1. This is the sub-triangle. Its area is A2. And this is the sub-triangle. Its area is A3. Now, let us see how these three natural coordinates vary. Okay, because they represent area coordinates, how they vary. At each point of the triangle. Right? Now, I say P coincides with 1. When P coincides with node 1, okay? When P coincides with node 1, A1 equals to A, A2 equals to 0 and A3 equals to 0. Therefore, the natural coordinate L1 equals to 1 at node 1. Remember, at node 1. And the natural coordinates L2 equals to 0 and L3 also equals to 0 at same node. That is node 1. Okay. Now, sum of the three natural coordinates you get unity. Sum of the natural coordinates is unity. Next, I assume that P coincides with node 2. Then, what I get? A equals to A2. When A equals to A2, okay, what you get? L1 equals to 0, L2 equals to 1 and L3 equals to 0. Because A1 equals to 0 and A3 equals to 0. Next, when P coincides with node 3, A equals to A3, A1 equals to 0, A2 equals to 0, therefore L3 equals to 1, L2 equals to 0 and L1 equals to 0 at node 3. What we understand ultimately, the natural coordinate L1 is unity. Natural coordinate L1 is unity at node 1. L2 and L3 are zeros at the same node. Next, natural coordinate L2 is unity at node 2. Natural coordinate L2 is unity at node 2. And L1 and L3 are each 0 at node 2. Next, natural coordinate L3 is unity at node 3. And L1 and L2 are zeros at node 3. And moreover, at each point on this triangle, sum of the natural coordinates is unity. Okay. Here students, what we have learned in this particular class, we have derived the natural coordinates for any point on a three-noded triangle. Okay. The natural coordinates represent area coordinates. The natural coordinate L1 is unity at node 1. At the same node, the remaining two natural coordinates are zeros. The natural coordinate L2 is unity at node 2. And the other two natural coordinates are zeros at the same node. The natural coordinate L3 is unity at node 3. And the other two natural coordinates are zeros. And moreover, at each point on the three-noded triangle, sum of the natural coordinates is unity. Okay? Thank you. Thank you very much.